In 2008, neuroscientists at Charité Hospital in Berlin discovered they could predict which button a person would press up to 10 seconds before that person was aware of their own intention. The researchers used fMRI, a brain scanner that tracks blood flow through neural tissue in real time. Participants lay inside the machine and watched a screen. On that screen, letters moved in a stream. When they felt ready, they pressed a button, left hand or right hand, freely chosen whenever they wanted. They also noted which letter was on the screen at the moment they first felt the urge to press. That letter was the timestamp of conscious intention. The researchers fed the brain data into a pattern recognition algorithm. The algorithm was trained to find signals that predicted the choice before it happened. And it found them in the prefrontal and parietal cortex, in regions associated with long-range planning and self-monitoring. Up to 10 seconds before the participant felt the intention to press, the brain had already encoded which hand they would use. The decision was already written. The person just hadn't read it yet. Free will is not a topic neuroscience picked because it was convenient. It is the oldest question consciousness asks itself. Am I the author of my own actions, or am I watching them happen and calling myself the author after the fact? The assumption embedded in daily life is clear. You deliberate, you weigh, you choose. The feeling of choosing, the sense of standing at a fork with options that genuinely depend on what you do next, is one of the most fundamental features of conscious experience. Philosophers built entire systems around it. Legal systems assume it. Moral responsibility depends on it. The neuroscience that began in the 1980s didn't set out to destroy this assumption. But it started finding data that were difficult to reconcile with the story consciousness tells about itself. The data kept saying the same thing. By the time you feel yourself deciding, the brain has already been moving for some time. The experiment that started this conversation was designed by Benjamin Libet at the University of California, San Francisco, in 1983. Libet asked participants to sit in front of a clock, a dot of light moving in a circle, and to perform a single, simple, spontaneous action. Flex their wrist whenever they felt like it. No cue, no instruction about timing. Just a free, voluntary movement made whenever the urge arose. As they watched the clock, they noted where the dot was when they first felt the conscious urge to move. Libet measured their brain activity with an EEG at the same time, and he found something that made the experiment famous. The brain had already been building activity several hundred milliseconds before the participants reported feeling the urge to move. The readiness potential, a slow wave that ramps up before voluntary movement, was detectable in the EEG an average of 350 milliseconds before the moment of conscious intention. The brain was already in motion. The feeling of deciding came later. Libet himself was careful about what to conclude. He pointed out that there was still a brief window, about 150 milliseconds, between the first conscious awareness of the urge and the actual movement. Time enough, he argued, for consciousness to veto the action. The brain starts the process, but the mind might still be able to stop it. It was a careful reading. But what most people took from the Libet experiment was simpler and more disturbing. Your brain decides before you do. What Libet found was 350 milliseconds, a third of a second. Fast enough that you might argue it was a timing error, a rounding artifact, the brain warming up rather than deciding. Soon and his colleagues at Charité and the Max Planck Institute found 10 seconds. That is not a rounding error. 10 seconds is the time it takes to read a sentence, to glance at a phone, to change your mind about what you were about to do. And in all that time, while you were still feeling undecided, still experiencing the open space of choosing, the pattern in your frontal cortex was already pointing to the outcome. The study used a more sophisticated method than Libet's EEG. Functional MRI allowed them to look not just at overall brain activity but at the spatial pattern of activity across different regions, and to decode which pattern corresponded to which choice. The algorithm wasn't detecting a generic decision-in-progress signal. It was detecting the specific content of the decision. Left or right, this one, not that one. And it could read that content before the person who made the decision knew what it was. The region that carried the most predictive information was the frontopolar cortex, the most anterior part of the frontal lobe, the structure most recently evolved in the human lineage, the region associated with prospective memory, with holding multiple possible futures in mind simultaneously. The very region built for thinking about what comes next had already made a choice about what would come next, before the consciousness using it knew what that choice was. Right now, something is building in your prefrontal cortex. Not a decision you have made or not one you're aware of having made, but a pattern, a drift towards something, a configuration of activity that, if a researcher with an fMRI and an algorithm were watching, might already be readable as a preference, a direction, a choice in progress. The feeling that you are about to decide, that the choice is still open, still genuinely yours to make, may be real. But the brain state that will produce that decision is already assembling itself before the feeling arrives. This is not a comfortable finding. It doesn't fit the story consciousness tells about itself, which is a story of authorship. I deliberated, I chose, I acted. The neuroscience says the sequence may be: the brain moved, you became aware of moving, you called the awareness the decision. The gap between those two stories is where the entire debate lives. But before you resolve it one way or another, before you conclude that free will is an illusion or that these experiments say nothing important about agency, consider what happened next. Because the experiment that seemed to close the question reopened it. In 2012, Aaron Scherger at Neurospin in France, together with Jacobo Sitt and Stanislas Dehaene, published a paper in the Proceedings of the National Academy of Sciences that proposed a different interpretation of everything that came before. Their argument was precise. The readiness potential, the slow ramping of brain activity that Libet identified as the unconscious initiation of voluntary movement, may not represent preparation. It may represent noise. The brain is never quiet. Neurons are firing continuously, in patterns that fluctuate randomly, a background of stochastic electrical activity that never fully settles. Scherger and his colleagues proposed that voluntary movement in Libet-style tasks occurs not when the brain decides to move, but when this ongoing fluctuating noise happens to cross a threshold. The moment the noise peaks high enough, the motor system tips into action. The readiness potential, they showed, looks exactly like what you would expect from random noise that gets time-locked to movement onset, an apparent ramp that is actually the tail end of a fluctuation that happened to reach threshold. If they're right, then what Libet measured was not the brain secretly making a decision before you do. It was the brain's background noise occasionally spiking high enough to trigger a movement, and consciousness noticing the spike and calling it a decision. This does not prove that free will exists. It does not restore the naive picture of the conscious mind as commander. But it changes what the evidence says. The readiness potential is no longer a signed confession from the unconscious. It may be a random process that gets labeled as intention after the fact, by the same consciousness that thought it was in charge all along. The signal precedes the thought. But the signal may not be what we thought it was. The neuroscience of free will has not resolved the question. 40 years after Libet sat people in front of a clock and watched their readiness potentials build before their intentions, the field is still arguing about what any of it means. What is clear is this: the story consciousness tells about decision-making, a story in which the moment of "I decide" is the origin of the action, is not accurate at the neural level. Something is happening before that moment. Whether that something is a decision, a preparation, or noise that gets retrospectively narrated as intention is still open. The brain precedes the feeling of choosing. The feeling of choosing may not be when the choosing happens. But it may not be nothing either. Libet's veto window, the 150 milliseconds in which consciousness might still be able to abort what the brain has already started, is small. But it exists. And Scherger's model suggests the decision the brain makes before you do may be less determined than it appears. More like a coin tossed by neural noise than a sealed verdict delivered from the unconscious. You are the process, not a passenger watching the process happen, not a commander issuing orders from outside it. The process that deliberates, that weighs, that notices the readiness potential and calls it intention, that is you. All of it, including the parts that happened before you noticed. The decision begins before the feeling of deciding. Whether that makes it less yours is the question the research opened and left open. What the brain does with questions it cannot close, how it holds open problems, carries them forward, returns to them in the middle of the night, is where this channel is going next.